Example 1. Determine whether the function is one-to-one. A. H is the set of ordered pairs 4, -5, +6, +1, +2, +4, and 0, -3. If we take and we draw in a mapping, and we want to map all the elements in the domain, these are the x-coordinates, over to all the elements of the range, and then back again, we can check to see if there's one-to-oneness. All right, so in the domain, we have the numbers 0 and 2 and 4 and 6. And then in the range, we have the numbers -5, -3, +1, and +4. All right, now remember, in order for it to be one-to-one, every element in the domain over here can only be matched up with one element in the range. 0, we know, can be matched with -3. +2, we know, is going to be matched with +4. +6, we know, is going to be matched with +1. And then +4, we can see it's going to be matched up here with +5. All right, now to check for one-to-one, now we have to check and make sure that every element in the range is also paired up with one element in the domain. So I know that -5 is paired up with +4. We have the pen here. This is not behaving. Okay. All right, so we have -5 paired with +4. We also have +1, which is going to be paired with +6. That's this way. And we have +4, which is going to be paired with +2. That's going to be this way. And then we got -3 that's going to be paired with 0. So each of the elements in the range is only paired with one element in the domain, and each element in the domain is paired with one and only one element in the range. So this is a function, and it is one-to-one. Now, when we go to look at the other problem, we have the set K of the ordered pairs +1, 0, +3, 0, and +4, -5. All right, so our domain consists of the numbers +1, +3, +4, and our range consists of the elements -5 and 0. And remember, we don't have to list 0 twice because it is not a different element from that one right there. Okay, now when we pair these up, going from the domain, we can see that 1 is paired with 0, and we can see that 3 is paired with 0, and we can see that 4 is paired with -5. So every element over here in the domain is paired with only one element over here in the range. So this function, well, this is a function. When we try and go the other direction, though, we can see that the -5 has been paired with the +4, but this 0 has been paired twice, once with a +1 and once with a +3. And so because we have two elements in the range, or one element in the range that's paired up with two things in the domain, this one is not going to be one-to-one. All right, so this one is not one-to-one, and this one is one-to-one over here. Okay, for example 2, we're supposed to use the horizontal line test to determine if a graph defines y as a one-to-one function of x. Now remember, to be a function, we do the vertical line test, and we're looking to see if the graph crosses a vertical line more than once. Well, for the one-to-one, we're going to draw in a horizontal line, any horizontal line, and we're trying to see if the graph crosses the horizontal line more than one time. If it does, then we say that the graph is not one-to-one. But if it does not, then we say the graph is one-to-one. Now for the first problem, in A here, we can draw a horizontal line right here, and we can see that this horizontal line crosses at this point and at this point here. So automatically we can say, all right, this one not going to be one-to-one. All right. All right, for graph B, when we're trying to determine if our graph is one-to-one or not, we can draw in a horizontal line